And we should be going live straight to Twitter and LinkedIn. And we should also be live on YouTube as well. This is where we ask everybody to at least mention that we're going. So there are 40 plus of you already in and ready to go. Thank you for joining at such short notice. Joining me is this guy, George. You may know him as Cheese from the Chips and Cheese.
Hello.
And yeah, we decided to have a fun, packed stream talking about all these things that are going on. Because, I mean, it's been a hell of a month. It's, I know George feels similarly. I've just got home after, 7 weeks on the road? Essentially.
That sounds like what you... Yeah, that sounds right, yeah.
Yeah, I think, 5 days and 30 I spent at home. Mixture of US and last-minute trips, and then Computex. And then one of those weeks was a vacation, workcation sort of thing. Night in a nice 37-degree heat in Bucharest, so that's fun. I am wearing the novel Full Nerd merch if you go watch the PC World guys, or you have the Tech Potato merch at merch.techtechpotato.com. It's nice and refreshing. This will be a stream.
George, so
We need to get George on the merch train. And as Darrell is saying, AI, this will be a strong theme. For better or worse, we'll try and steer it towards the realms of normality in this stream. Yes, as Nick says, don't forget to like the video if you just happen to be on YouTube. We should be simulcasting to Twitter and LinkedIn as well, hopefully. And the first thing I'd like to bring up actually is more of a admin, and that's because we need to talk about chips and cheese. This is what George writes for. If you love in-depth in-depth chip analysis, AI just happens to be the consequence rather than reality. I'm actually lost where I've put that. Here we go. Yes.
Yeah, it's right there.
And so you can see that at Chips and Cheese they do nice articles like Mi300X and Nintendo Switch. And we're going to go through some of these articles today, just because, as you can see, June, May, there's been a lot going on, particularly. But yeah, if you're in-depth analysis and microarchitecture, then please do go over to Chips and Cheese. But the first topic, if I can bring it up, is the State of the Union. So, George, would you like to talk about what this State of the Union is? This was posted a couple of months ago, but I think it's really important for people to understand what's been going on.
Yeah, so the State of the Union was basically what is happening in the chips and cheese world right now. And
a bit closer to your mic, George.
Oh, sorry. So basically what's happening in the chips and cheese world and why we decided to make chips and cheese a nonprofit.
So I think that's the big one. You know, 3.5 years Chips and Cheese has been around, and as of this year, we are official. Chips and Cheese is officially a non-profit. So for people outside the US, that means 501c3. So companies can donate to the charity and it being a tax write-off. But what does it mean that Chips and Cheese is a 501c3? What are you providing to the community?
So what we're providing is, well, our, for lack of a better word, analysis. Like, I don't think it's necessarily, I don't think it's controversial to say that of the mainstream English tech scenes, we are probably the most in depth. We probably go very deep into the architecture, and we very much look at the nitty gritty. We also provide our tools on GitHub. There are major reworks coming, as outlined in the State of the Union. But another big part is the formation of the board. We had to form a board, as well as
okay. Let's go over the mission statement first.
Yeah.
To educate the public on technical topics, to build and maintain a set of in-house tools to test and evaluate technological products, to release a useful set of these tools as open source software to inspire curiosity in our audience. I think we're both, and I hope most of the audience is well aware that companies have lots of internal tools to tell you how their chips perform, and very few of them are ever made public. And I think one of the goals of Chips and Cheese is to try and help tease out some useful tools that everybody can use through open source. And
Yes.
And to date, Chips and Cheese has some tools available online, though they are very much the first write of these tools. And there's going to be a framework for which more tools can be added, easier to use. People can pick and choose what they need. If some knowledge will be needed to use them, there won't be click and run.
Yeah,
it won't be a bench or a geek bench. It will be you need to know what you're looking after to get the best out of these tools, which I think for as in depth, for as complicated as these chips are, that's a very, I think, a low bar for a chip architect to reach.
Yeah. And we are trying to improve right now our big focus on the tests are to improve the framework so that folks can extend the tests, not just with new tests, but also say a different way of doing a old test. Like we have two different ROD tests. We maybe in the future we'll have 3 or 4 just as cross references.
And is it just github.com chips and cheese?
Yes.
Yeah.
These are old, and we're fixing this up, and we're getting all the framework in order. So there's a lot of changes coming, but right now it's sort of stagnant at the moment. But
it's all right. It's
promise that we are getting stuff done.
It's and it's probably at this point we have members of the board. So we have elected a board, and George is president. I'm vice president. So I am involved in Chips and Cheese. YouTube's telling me to go insert ads. Go away. So yeah, you may recognize some of these names if you follow us on Twitter. Chester, Felix. If you're wondering who Clam Chowder is, that's Chester here. And yeah, that's kind of the State of the Union. 501c3. We elected a board, and we have a goal.
Yes.
And we're also in the process of trying to work out the best way to present all the information that Chips and Cheese provides. So that's alongside the reviews and the tools and the updates and how to get everybody involved.
Mr. Victus, there might be some there might be some updates to that coming soon, potentially.
So the question is from Mr. Viptis: has Chips and Cheese considered posting to YouTube? So that was funny because it's something George and I have spoken about for a while, and hence why we do things like this as well on the Tech Potato channel. So there's the plug. Please do go subscribe to Chips and Cheese. You know, the devil is in the details. And if you want a 20-year-old review of Pentium 4, there's one of those in here too. So that's fun. Let's talk about Computex. So Computex, those of you who are not familiar with Computex, it is a week-long show in Taiwan every year, usually end of May, beginning of June. It's a trade show, right? I think they said 85,000 people this year attended. And yeah. And this year was the second year post-COVID as well. This was your second time at the show, George.
Yes.
This, as far as I understand it, this is also the first show since the pandemic that the mainland Chinese press were allowed, because of some issues last time they weren't allowed. So that's why it felt a lot bigger. And I know going around the show floor, days 1 and 2 were absolutely intense, especially if you had camera equipment. But it is a show where, if timelines align, there are plenty of keynotes and lots of things going on. I'm going to share this tab if I can bring us in. Oh, that's incredibly zoomed in. So if you don't know, if you only know me from Tech Potato, I also have a blog of my own, a newsletter posted regularly called More Than More. You can see the just here. There's a link just here, or that more-more.com, and this is where I do my written work post and Antech as well. And in here we have some of these, some of the Computex stuff that came out of Computex 2024, mostly Q&A with CEOs, and some announcements. Just to clarify, these are press roundtables. This isn't me giving the Q&A. Otherwise, it'd be a lot better. Unfortunately, when you have a room of 200 press and the CEO, everybody asks a different question on a different topic. So if you're interested in gaming, if there's one person who wants gaming, we'll go through some of these through the course of today's live stream. But yeah, Computex is big. George, how did you find it this year?
It was more intense this year, honestly. Last year, it was not as... Last year, I did not have as many meetings personally as I did this year. This year, I had a ton more meetings and a ton more things to do, so to speak.
You planned better because it was your second rodeo.
Yes, essentially, yeah. But yeah, I did book some time basically to just go on the show floor and walk around, which you should always do at a event like Computex, because you get to see some really cool things. And I think something that we can sort of move to is Cam 2.
Yeah, let's see if I can share this.
Speaking of cool
screen.
Things.
Okay, you start us off. I'll try and find the because I've got about 15 million windows open right now.
We're all used to the I used to have one right here, but the standard DIM, like DDR5 or DDR4 DIM, and DIM slots and all that. With Cam, that's kind of gone. You have one.
So we're talking about these things here.
Yes.
Right. These have been standard for what? 20 plus years at this point.
I think
you buy your memory, you stick it in.
Has been standard what? Since DIM, like all the way back with like probably the 80s, something like that.
The idea being that you can have any amount of memory on your system as you like, as long as you have a fixed number of DIM slots, and you can buy different vendors and different capacities, and over time, there's new technologies that might have different way the pins are selected. So DDR4, DDR5, obviously the latest ones, and this is an attempt to do something new called Cam 2. Is this a Micron specific technology? Do you remember?
So this was originally a Dell technology so Cam 1 was a Dell technology that they then gave to the JEDEC board, JEDEC being the guys who basically dictate all the memory standards. And that was then updated into Cam 2, as well as sort of a counterpart, LP Cam 2, which is for LP DDR5. versus Cam2, which is DDR5.
So I think it's important to realize that Dell designed it essentially for notebooks because they wanted something that was upgradable like normal SODIMMs, but also lower in Z height and better for airflow and ergonomics like soldered on LPDDR. So they developed CAM, which was specifically an LP CAM, so low power DDR5. And then for whatever reason, and I think this was a little bit unexpected, most of the motherboard vendors do a standard DDR5 version and stick it on modern motherboards. And it means that you go from 4 modules down to 1. But that one module has all the memory. And I've been told it's cheaper than if you buy 4 of the highest capacity modules per gigabyte. So there is some overhead,
for the same capacity, correct?
Yes, yeah. So if you had 128 gigabytes on a Cam2, I'm skipped then. Is
did you break up?
Weird. Yeah.
Okay.
So, and think the idea is that you have 4 modules and you're a board vendor. You have to be able to essentially build the board to support 1, 2, 3, or 4, single rank, dual rank, low capacity, high capacity, everything. With Cam2, you just put in one thing and it's consistent.
Yeah. Which actually does simplify a lot of the trace layout stuff that DIMMs have been notorious for.
Yeah, okay, it's being a bit screwy, sorry. So this is the DDR5 spec. There's an LP DDR5 spec for notebooks. Not interchangeable, but it's thinner to the motherboard. Airflow is better. I've been told it's more overclockable. And technically stackable. The spec allows for stack on stack stack. Yeah.
Honestly, I'm all for it. I actually think it's really cool. And especially if we can get LP DDR onto consumer boards, I think that would be great.
I mean, just as simply as a complete replacement, I think. Let me see if I can change Windows here, because I also have the MSI version. Bear with me. It won't let me stack up screens in the software. So this is the MSI one. And you can see where it is to the board. Yeah, it just sits just slightly off it, like an M.2 module.
So Ian, chat is saying that you're breaking up quite a bit.
Yeah, I don't know what's going on. This is what happens with where I am in London. I need my gigabits. And this, if we can get it on, we took 1 million photos. This is a great picture because it shows that you can just have a water block over the memory. Right?
I mean, to be fair, we've had that before, but it's always sort of been a bit ho-hum in terms of the actual implementation.
Yeah, this is MSI's block. Did we and they did this thing called mini CUDIM, which we won't get into, which is another attempt at differentiating memory. But yes, Cam 2, LPCAM, Microsoft Micron was showing off some some DDR5 9600 modules. So with consistency comes higher memory. Yeah, sounds really good. Mr. Vipitis asks, is there a server solution for Cam 2? Not yet. However, things like CXL may solve that. So it's and at this point, what are we, 20 minutes in? We actually have a sponsor for this stream, would you believe it or not? And I've got a pre-prepared video to play, and we've got to say thank you to ASM for sponsoring the video.
This video sponsor ASM. One of the pioneers of modern semiconductor manufacturing equipment is ASM, a company on the leading edge of wafer processing equipment manufacturing who have sponsored this section of the video. ASM specializes in making equipment to build layers of silicon 1 atom thick, known as atomic layer deposition, in a highly controlled fashion, so much that they have 55% of this market. In this video, we're talking about chips, and ASM builds the stuff for those chips. Epitaxy for silicon-based layers and chemical vapor deposition, with dopants added to optimize the material properties for thin film production. And thin film production is likely going to be needed for next generation 3D transistor designs. As we progress to more advanced manufacturing, expertise becomes vital. And to find out more information on ASM and their portfolio, head on over to the link in the description today.
So a big thank you again to ASM for sponsoring this stream. It helps keep the lights on. I think George needs to turn his lights on, maybe.
Hey, I can turn that light on. I have a second light there that I could turn on if it's really bad. But I can't open this blind, otherwise that camera just goes wonky. So
it's funny that you ask, is there a coupon code in the video description for 10% off? I'm the sort of YouTuber, analyst, influencer that, companies like Applied Materials and SciTime, and I'm doing a video about air freight shipping, and I don't think there's a code for 10% off your first EUV machine. Or 10% off shipping your first EUV machine. It's really great that we can actually have sponsors from companies in the industry that are as big as ASM and who understands that there's an audience to talk to here. So be on the lookout for some upcoming shorts and videos that may also be interesting and sponsored as well. So let's go to the first topic of Computex, and we're going to do this by company. George and I hammered out a rough step-by-step guide in advance, and let's see if I can share this screen. Before I do, I'm going to bring in High Yield. Thanks for the 10 euros, mate. You didn't have to. We met Max from High Yield at Computex. Great guy to speak to. We should get him on the channel as well. Eating applesauce and watching you and George can't get any better. Was really fun meeting you guys at Computex. I think High Yield. I think the question is, will you be back? I think you really enjoyed, and one of the reasons you probably enjoyed was because of this. And again, let me get my screen share up. Let's start with Intel, and I would go through the keynote with Intel, but I think first we want to speak about Tech Day, really. So Intel had a Tech Day. Now, Intel has Tech Days. AMD has Tech Days. Qualcomm has Tech Days. Intel, for the last few years, has had what we call a Tech Tour. So 2 years ago, it was in Israel. Last year, it was in Malaysia. And the focus of those events was essentially, understand how Intel works at the foundry level. This year was a Tech Tour in Taiwan, and it didn't have any it didn't have any tour. The tour was the architecture. And George has a funny story about how you turned up for this.
So
I should point out, I get invited to all this stuff because I've been in the industry, 10, almost 15 years at this point. Also, it helps that, full disclosure, a lot of the companies we're speaking about today are my consulting clients. That doesn't mean I go easy on them. They don't pay me to be a yes man. But George is relatively new to the industry, so George wasn't invited initially.
No. So I don't quite know what happened on your end, but I know from my end, I was emailing folks at Intel asking for an invite and was basically told no. Like, you weren't even supposed to know about this. No, you're not invited. I'm like, okay, so cool. So I guess I'm not going. Well, I already wanted, because I loved my time in Taiwan the first time. So I went and sort of added a few extra days to each end to my trip there. So was flying in the second day of the tech tour. I get onto a plane, and I'm on a plane with no internet. I don't know what happened then, but by the time I land, I basically get a Discord message saying, yeah, turn up at my hotel at 8 a.m. tomorrow. We're going to the tech tour. I'm like, okay.
So the tech tour was a 2-day event. And it was, planet architect deep dive, one-on-one with the engineers. And at the end of the first day, one of the engineers comes over to me and says, well, I went over to him, just to say thanks for the in-depth presentation. We'll get into that in a bit. And he said, oh, do you know George from Chips and Cheese? I'm like, yeah. And he said, here's my number. Let's arrange dinner. And I'm like, well, he's flying in tonight. Do you want to do it tonight or tomorrow? And he's like, let's probably do it tomorrow. And then that was in the morning. Then in the afternoon, the person who actually organized the event came to me and said, hey, do you know George from Chips and Cheese? And I said, yes. I've been telling you about him for over a year. He wasn't invited, but he's in town. And he's like, can you make the introduction, please? And I'm like, yeah, I can get him here in the morning. And you arrived in the morning, and you met the guy you had to, and you met the engineer, and you got it's. I think it was important for you to make the connections more than the content you caught up afterwards.
Yes,
but it was the presentation, the connections that you made. So with any luck, you should be hopefully invited to future events, or at least get on the briefings for deep architecture. And it's good because they got a few articles out of you, which we'll go into.
Yes,
for attending that event. But yeah, there were sessions on the new Lunar Lake, which we'll get into, the P cores, the new E cores, and the new Xeon, and we'll cover all of those quickly.
Also, the new iGPU in Lunar Lake.
Yeah, all of Lunar Lake. So what I'm going to start with actually is let's go through the keynote, just because everybody does a keynote, and it will cover actually most of the stuff we're going to talk about here. Intel had an official keynote, and as I've said in my thread, let me get up here. This is the first time an Intel CEO has keynoted at Computex. And I'll show up Anastasia in tech. She sends another 10 euros. Again, you guys, you don't have to. We all know and love you. So let's start off with Intel. It starts with Intel. So if you don't follow me on Twitter, when these things happen, I do a Twitter thread. So just because it's easy. And let's see if this plays the audio. So this is like the first few minutes before it starts. These people aren't AI generated, by the way. And then before it starts, we see, ooh, what's this, a wafer? Pat to the stage. Pat's very memeable. He always has lots of facial expressions if you're getting close. I was just doing this with a smartphone. So Computex started in 1981, year at the 286, and here's, what chip is this, George?
That doesn't look like anything that I immediately recognize.
Those look like SerDes links. Those look like cores. Those look like more SerDes links. It almost looks like IBM Z.
Yeah.
Anyway, we'll get it in. And yeah, his big thing was, despite what Jensen will have you believe, Moore's law is alive and well. Yeah, next year it's the 40th. Intel will be in Taiwan for 40 years, so there might be a big event there. And here we get into AI, starting with Intel Foundry. Now, you may or may not know that Intel has now separated financially the products from the Foundry. So there's a big focus on Foundry as being a revenue generator over the next decade. And with a Foundry, you can do AI. And Intel knows how to enable at scale. This was his theme. Jensen talks about AI supercomputers, AI factories. Pat is talking about reimagining the data center, because people understand what a data center is. Nobody knows what an AI factory is, really. And the first announcement of the day, launching Xeon with E-cores. This is Sierra Forest, the 144 core version, if I remember correctly.
Yes.
And it looks like this. So this is Intel actually going chiplet, proper chiplet this time. So they're reusing an I/O die. They are the same on both sides, and then a centralized 144 core E-core die. And here's me having a bite of one at the tech tour, because you've got to. And there it actually is. And I have way too many buttons undone on this shirt. It was very warm. But here they're saying you can use it for video streams. Though why you wouldn't exactly use a flex GPU for video, I don't know. Maybe this is probably like 720p H.264 conversion anyway. So 4.2x uplift, 2nd gen to 5th gen, 6th gen, and consolidation. So one of the things with enterprise is they always say multi-year. These things are installed for 3 to 5 years. So if you're updating a 5-year-old system, you get a 3-to-1 consolidation with energy saved, though, you have to actually buy it. So it will cost. And this is the version coming later this year. Different socket, but two chips, 288 cores. And then P-core version, this is Granite Rapids.
Yes.
And this is the big Granite Rapids as well.
Yeah, that's the 128 core. Though they likely have more cores on die, because 128 does not split into 3 cleanly.
Yes.
So
yes.
they likely have more cores on each die than 128, but their SKUs top out at 128.
Yeah, probably something like, I don't know, 38, 40 maybe?
I think...
No, sorry, more than that.
43 or 44, I think, is what I was guessing at.
So, yeah, and lots of partners already enabling Xeon 6, because Intel has extensive stuff. Now we get into AI, and let's talk about RAG, Retrieval Augmented Generation. If you've not heard this term, it basically means let's look up a database with your result to get better accuracy, and Gaudi 2. This is the AI chip that Intel's had out in the market for a while. And this is I think, the surprising AI announcement from Intel. They actually announced pricing. Nobody announces pricing for AI. And they've straight up and said 8 Gaudi 2s with the board in the OEM form factor, 65,000, or you can get a Gaudi 3 for 125,000. They believe this is 2 to 3x cheaper than the competition. So what Nvidia DGX with like 8 hoppers is what, 350, 400,000? But that's a fully built-in system, all in, plus tax. Nobody pays that much, but yeah.
I think the estimated going rate is somewhere around 300K for a DGX box.
Yeah. And yeah, Miss 50 says Supermicro has announced a 8x8-way Gaudi box for 90K. And the thing is, they can ship these today as well. You don't have to have a 52-week lead time to get them. You know, multiple partners as well. Partners to the stage. Throughout these keynotes that we'll go through today, I basically ignored most of the partners because it is what it is.
Now, this is actually interesting. If you go back, show that slide. UA link down.
Oh, sorry. Yep.
Yeah, UA link. Interesting to see Intel partnering with AMD on that. Considering that, as far as I'm aware, UA link is effectively a version of Infinity Fabric.
So what we have here is basically when there are 10 AI players in the room, if one company is 95% of the market, then the other 9 will gang up on the one. And this is the attempt to gang up. So Ultra Ethernet is basically the competition to InfiniBand. And UA Link is the competition to NVLink. Now, as George says, normally Intel likes having its fingers, in the pies for all of these standards. But this is the one that got away from them, kind of like 64-bit. So this is a competitor to NVLink, basically. And Jensen, if you go to more-more.com and NVIDIA's Q&A with Jensen, he actually touches on the topic of UA Link versus NVLink. And then, yeah, so Pat committing to like edge deployments running AI, expectations it's going to be massive, working with Samsung. And then we come on to AI PC, which will be a common theme during the rest of this stream, even though we're 35 minutes in. AI PC just means PC that can run AI, though realistically it's PC with a NPU, so dedicated AI unit. And the way Intel looking at this is essentially Wi-Fi. Centrino was a wake-up moment in the industry that everybody now had to support Wi-Fi. Well, now everybody has to support AI. That's what they're talking about. So they're predicting 40 million units AI PCs shipped by the end of the year. 8 million to date. So 32 million in 7 months. That's a tall order, don't you think?
Yeah. I mean, I guess part of comes back to what is an AI PC?
So that 8 million shipped to date is every Meteor Lake notebook. Because they have NPUs in, and I use mine, and it runs. But what they're saying is that, all these partners. Realize you can't see my mouse necessarily. Yeah, all these partners have AI PCs. Lenovo with the dual screen there. They're even including the MSI Claw in AI PC. Hey, it might run some AI. We don't know. And then Satya appeared in every keynote we're going to talk about today. But then also, so the successor to Meteor Lake is called Lunar Lake. We can talk about Lunar Lake in a second. But this is like the onboard LP DDR chip with new cores. We'll get into the new cores as well because that's a big part of Tech Day. And there's me eating Lunar Lake because you gotta.
Which one was more tasty, Lunar Lake or Sapphire Rapid? Sierra Forest, excuse me.
Lunar Lake had more flavor, but Sierra Forest had more volume. Sometimes you want flavor, sometimes you want volume. And here, Lunar Lake, Intel is saying up to 48 tops. That's in Tate, and a big thing being the power. So this is almost 5 times more tops than Meteor Lake. I think George is getting a package.
A car alarm was going off. Sorry.
Is your Lunar Lake arriving?
Yes, I can see it right out my window.
So the interesting thing is with Lunar Lake, you got this dedicated NPU, 48 tops, but then you have 67 tops on the GPU anyway. And the idea is that the NPU is lower power for that sort of compute. So a blurry Gelsinger. And they're saying that they've got 80 designs coming to market by end of year. So they're aiming for holiday seasons. I'm expecting an October/November launch.
Mm.
And then, more partners to the stage. They also spoke about roadmap. Arrow Lake coming in Q4. So Luna for notebooks, Arrow Lake for everything. And the way to pinpoint this is Luna Lake is going to be thin and light premium designs, right? Where battery life is paramount. Arrow Lake is going to be everything. So as you can see, it's going to be in a desktop form factor. Does Arrow Lake and Lunar Lake, are they the same architecture? Do we know that yet?
We'll get into that, but there's some stuff about how Intel architected Lion Cove that could point to potentially some differences between Arrow Lake and Lunar Lake.
Yeah. Okay. Cool. And then we have a nice close-up of what an Arrow Lake chip looks like. Count the cores.
I think it's 6 plus 8, but
it's, for me, I'm not. They could have pulled out any wafer. This could have been a test run or a failed thing. It's definitely not a working wafer. Let's put it that way.
Yeah, no.
But yeah, no. I managed to take this photo of what was on the screen to the side of Pat. This wasn't a close-up, unfortunately. Acer to the stage. Intel talking about the fact that it's end-to-end. This sort of, not only do we design the chip, we also build it, and we do the software. Almost like, Apple doesn't make the chip. That was their argument. But Intel doesn't make the notebook. So 6 and 1. And then a few more partners. And then that was the keynote. Very, it was what, an hour and 10 minutes, if that. Went over a lot of things. And I want to bring this up because it's very important. George.
So
sorry, go on.
Yeah, so to quickly cover basically the major changes in Lion Cove, there were 3 big changes.
So describe what Lion Cove is.
So Lion Cove is the successor to Redwood Cove, which is found in Meteor Lake. Redwood Cove was a slight improvement on the Golden Cove architecture found in Golden Cove and Raptor Cove architecture found in Alder Lake and Raptor Lake. But this is a major jump. This is a big changes are coming with Lion Cove. The 3 big ones that I outlined here were, the first one was the splitting of the scheduler. So in prior Intel CPUs, they had what was known as a unified math scheduler. That meant that all your vector instructions, FP instructions, and integer instructions were all funneled through the same scheduler. With Lion Cove, they've now split it out so that you have an integer scheduler and a vector scheduler, much more like AMD's Zen series of CPUs.
AMD's been that way since Zen 1.
Yeah, no, AMD's had essentially a separate FP/vector scheduler and an integer scheduler since, I want to say, K7.
Well, I mean, at least in terms of modern chips, from the first 10, ARM CPUs have been essentially like this for forever as well.
Mm-hmm.
And Intel's own E-cores do this already.
Yes.
So the fact that the P-core was the last one to do this matters. But also, it was done for a sense of scalability. A unified scheduler scales horribly over a certain size, especially power, because you've got to keep the whole. Sorry, go on.
Well, it scales horribly because you also have to consider all the, in order to, what a vector scheduler needs is going to be different than what an integer scheduler needs in terms of the networks applied with bypassing UOPs and stuff like that. So splitting it out means that you can have essentially a simpler but bigger integer scheduler and a smaller but more complicated vector scheduler instead of trying to cram it all into one scheduler.
Basically, a big update. It's surprising, really, it took Intel that long to bring it into their P core. Should be better.
Yeah.
Number 2 is
cache
this
hierarchy
cache.
changes.
Oh, gee, this blindsided me. I thought, no, this couldn't be the case.
So the rumor mill was saying that this was a possibility. And if you think of it as, so the L0 is the old L1. That they renamed it L0, but that's because they didn't want to name their new L1 L1.5 because they thought that was too confusing.
Yep.
But the L0 is what was the old L1, just with 1 cycle less latency, which is nice, very nice. That's your lowest level cache. That's going to be your fastest cache. Latency really matters there. Then you have this new intermediate L1 cache. And what this is playing at is a bigger cache than your L0, but a faster cache, like in terms of latency, than your L2. Because
so CPUs have cache because you need data very close to the core in a very fast read-write set of memory. But the thing is, having it that close to the core is actually really expensive in terms of capacity. You only have so much die area to play with. So a cache hierarchy allows the trade-off between capacity and speed. And traditionally, most modern cores have a private L1 and a private L2. And this is what we see at the top here, this Redwood Cove. So you're looking at this L1 and L2 cache. Capacity, in this case, 48 kilobytes and 2 megabytes. And this load to use column, that's how many cycles it takes to essentially load data from it to then be able to use it in an execution port. And, every cycle matters in a design, especially at high frequency. 5 is actually relatively slow for an L1 cache in a modern core. Most are 4, some are even 3, though the ones that do 3 do take some liberties sometime. But this is the fastest. Not every instruction will do this. Not every operation will do this. So this is the fastest load to store. So the fact we've gone from 5 and 16 to 4, 9, and 17, if you draw a graph from 0 bytes to 2 megabytes, the point is the average latency over time means that it's, at the end of the day, better. The only thing is you have to manage where the data is. And so we could go into inclusivity and exclusivity and this Intel's, partial exclusivity sort of thing. But at the end of the day, these are all private caches per core. And if it means fewer misses, so for example, if you wanted something in like the 64 kilobyte region, now it's only 9 cycles away rather than 16.
Yeah.
And that's the benefit you get out of it. And being on a smaller process node, a denser process node, means you can fit more transistors in. We should say this is on TSMC's N3, N3B. So a lot of big discussion about Intel using TSMC. We can get into that in a bit. But yeah, one of the benefits of more transistors, people say, how do we get Moore's law out of more transistors? It's by having bigger caches closer so they're lower latency.
So
what did I miss?
No, just sort of adding on, that new L1 also lets Intel expand their L2, as you see, from 2 megs to 2.5/3 megs without having to incur too many cycles. You can still have this sort of lower level fast cache and expand that L2 and have that go up a few cycles.
Thanks to Nana Gopal for the 400 rupees. Really appreciate it, man. Thank you. To the smaller side.
Now,
but yeah, it's going to be fun testing this cache to see exactly how it lines up. because the L2 cache in Xeon 5 Emerald Rapids was 5 megabytes because they said, screw it, let's make it massive. The fact that this isn't a small chip that you saw me eating, 2.5, 3 meg, that's quite impressive.
And so going back
George goes through all of this in the article, by the way.
Yeah, but one notable difference, if you scroll just a little bit down there, that last paragraph, that is potentially a notable difference between Arrow Lake and Lunar Lake. Intel has not confirmed this, but on what Arrow Lake can do. But on Lunar Lake, the bandwidth from the L1 to the L2 has been reduced from the theoretical 128 bytes per cycle to 64 bytes per cycle. The reason for this is power and area savings. Now, potentially with Arrow Lake, they could bump it up to 128 bytes per cycle. That would be a big difference. You could pull through more vector instructions.
But also, because you're pulling more from L1, you maybe don't need the bandwidth as much.
Well, and Lunar Lake is a lower power chip, right? So pulling back only 64 bytes per cycle, that's still 2 AVX instructions per cycle. Yep. That's still really good. So I very much can see reasons for why they did that.
And the last thing on the P cores,
hyper-threading optional.
I didn't want to believe this when I heard people rumoring about it, because I've gone over what it takes to build a hyper-thread core before, at least to a number of people, maybe not on video. But the point is, when you design a core with hyper-threading in mind, you have to budget for all the caches, all the buffers, all the entry tables, everything. And then you also have to manage the security between the threads and whether it's a dynamic allocation or a static allocation. AMD actually did a good job describing this through Zen 1 and Zen 2 and Zen 3 when they were still iterating on making the whole core a dynamically shared core between multiple threads. But the common misconception is that you can take a core and add hyperthreading, and you can't. So what Intel has done here is purposefully designed this core to not have hyperthreading. That means that they can actually reduce some of the bandwidth and buffer sizes from a hyperthreaded design, like George said with the L2. And yeah, it means that Lunar Lake's going to have fewer threads than everybody else. The one benefit is security. No longer have to deal with kernel boundaries with security. And the idea is that if you have an efficiency optimized P core, if you design, as I said, you design it with hyperthreading in mind, simply turning hyperthreading off still means that you consume massive amounts of power, because now one thread has a whole big core that was designed for 2. So having this one thread optimized, Intel is saying plus 15% performance per watt, 10% performance per area, and 30% performance power area. The thing is, this is what ARM CPUs do already. 1 thread per core. And in the land of cloud, where we're starting to see the high performance instances being 1 thread per core, this matters.
So to me, the story is not necessarily that hyperthreading is optional. To me, the story is that they've parameterized their cores to the point that they are able to do this optimization. I mean, that slide right there, sort of, it shows.
This is. I wish you'd have been in the in the session that had this slide, because I think you would have realized the same time I did, and I think it went over a lot of people's heads in the room. So Intel, historically, all of its cores for the last 20 years have been built using Intel's custom tools, right? This is stuff Intel's developed internally. They have their own EDA, they have their own multi-physics pretty much. And one of the reasons why Intel Foundry never worked before is because customers wouldn't be allowed to use Intel tools to design chips on Intel process. What Intel has had to do with Lunar Lake, because it's using TSMC, is they've had to use industry standard tools. So this is Synopsys, this is Cadence, this is Siemens, and as far as I'm aware, they're using all of them. Sune in the chat asks about, will all line code cores be the same? I will answer this when I get there. But all the tools that the standard EDA vendors are using now have a lot of optimization, AI optimization in them. It's AI, it's machine learning, it's whatever it is. But what it means is that Intel can go and make a specification for a chip, a core without hyperthreading, a core with hyperthreading. And the time to market from making that decision to getting an optimized design to taping out and production is now significantly shorter than it ever used to be. So now you can essentially have line Cove without hyperthreading. And if you want one with hyperthreading design, you go back a few cycles in your software tools, say, actually, no, we do want hyperthreading in. That means that these sections need to get bigger. Now you go tell the machine learning, go build it in the most power efficient way possible, or with optimal frequency, those standard banana curves with wire delay and stuff. The ability, the benefit of Intel now using standard EDA tools rather than having to optimize their own is that this level of configurability within their core now becomes substantially greater. They have more degrees of freedom. It does mean if you call multiple things line Cove, it's really freaking annoying because they could be substantially different in design and built on different nodes. It's this 99% process node agnostic. They're not joking. So the when they say sea of fubs, sorry, my mouse is over the wrong thing. When they say sea of fubs, they mean sea of functional blocks, whereas this is a sea of cells. So this is one layer down, optimized. So it's interesting enough. Kevin Cameron says they don't have much AI in the EDA tools. So I recently took on Synopsys as a client, and we're actually going through that right now. To a large extent, the ideas are there. The point is getting to it faster. Right now, a lot of that work is being done with specific partners in mind. And you can imagine Intel giving up some money to be one of those primary partners to do it. So it's an interesting time. And it all comes through the fact that they didn't need to present this slide. Nobody would have been any of the wiser. But I'm really glad they did.
To me, this shows confidence in what they've built here, and I think they really should be showing us off.
Yeah, I mean, we will see it over time, not with Xeon 6, but probably with Xeon 7, Xeon 8, and as Intel feels out the rest of the the rest of the product family, we could see it in networking, we could see it in embedded, faster time to market, that sort of stuff. We spent a long time on Line Cove. I highly recommend going through the rest of George's article if you want to get into the nitty gritty. But what they're saying here is an IPC uplift of 14% over Meteor Lake. Bearing in mind that performance and IPC different. Exact frequency we still don't know, but with using TSMC N3 versus an Intel 7, we should expect a better performance per watt. Almost even if people complained that Meteor Lake didn't produce a sizable increase in performance, but Meteor Lake was all about power efficiency really, and it looks like Lion Cove, because of where it's targeted, will be of a similar ilk. But still with a performance uplift. So we'll have to see. They said holiday season. So start of Q4. If you like Chips and Cheese articles, don't forget to head on over to their Patreon. We'll say that several times through this. But that we're going to have to scarper through the rest of Intel in order to reach everybody else.
Yeah, so real quick, moving on to Skymont, which is the new E-cores, the successor to Gracemont and Crestmont. The big thing here is it's bigger. It's kind of huge. In some ways,
the thing I want to say here is, in order to make the more efficient core, you need to make it massive,
which is almost opposite of what you would think. But yeah.
Whereas, the performance core is essentially thin, fast with vector. This is fat, slow, but efficient.
Like, don't get me wrong, the P core is very wide, but still, this is even bigger in certain areas, such as number of ports. I do apologize for hitting my mic. Sorry about that.
Briefly, I want to go over the highlights because again, we need to.
So briefly, highlights. We now have
3 decoders.
Yep. This fit better with how x86 does with the traces that Intel does. This three-way decoders fit better than 2 4-way decoders. That's why they did this.
Yep. So this is Skymont compared to Crestmont. You spent time with one of the lead architects for E-cores.
Yes, Stephen
and this is where you're getting some of the information. And decode, doing some special things to unlock parallelism within a decode cluster. Again, George goes into substantial detail.
Clam. So Clam went into very much detail.
But yeah, and then the back end. This is where we say it's getting super wide.
So a little bit of a note with that 18 wide retire. 16 wide retire, not 8 wide. That might not. So if, like you were saying about the Zen slides back from like the Zen 1 era, they talked about how, yes, they have 8 wide retire, but not all instructions, but not all instructions can. So for example, you may not be able to retire 16 add instructions all at the same time. Maybe you can only do 8. This might be going from 4 add instructions in Crestmont to 8 in
as always, these numbers are peak, and you only really hit peak in artificial workloads. But as codes are being developed, I mean, they're pushing E-cores for some AI use cases as well. Hence why deeper queues, lots of just bigger, and you can see, this is it 26 execution ports?
Yes.
Versus 4, 8, 12.
So no, there's no vector on this end.
Okay.
So there would be an extra 3. So there would be 15 ports for Crestmont and a total of 26 for Skymont. The vector is not shown in this diagram for either. Yeah,
but it's massive. And then they've doubled the vector width from 2 128-bit to 4 128-bit.
No, they've increased it by 1 pipe. So
3 to 4.
Yes.
To be honest, the shorter latency is also going to be important here.
That third port on Crestmont could do what's known as integer SIMD. So that's like 256-bit integer numbers. It could not do FMA or FAD as far as I'm
aware. Here you go. We talk about vector, FP rounding. So this is for integer 8 operations in AI.
Actually, this is for FP operations.
Oh, okay.
This is rounding the decimal point.
Oh,
yes.
I think I may actually need to read this a bit closer. And then on the memory, they still got a shared cache between 4 cores, so it's you still do have that trade-off. You can still roughly fit 4 E cores into one P core. It's actually a little bit bigger. 4 E cores is slightly bigger.
And well, this matters to some people. It's not really that useful in most code. The L1 to L1 transfer, so that means that you can go from one core in the cluster to the other without having to go out to your L3. You can just stay in the L2, which is nice. Locks aren't super common, so how useful that is debatable, but they can now do L1 to L1 transfers, which is really nice.
Yeah, and this is kind of like a bit of a description here. In terms of performance, I actually have a bone to pick with Intel on this. So they compared Skymont architecture, so this new E-core, to the low-powered E-cores.
So this slide is not that. This slide is comparing to Raptor Cove.
The P cores.
Yes.
So this is against Meteor Lake P cores. Now this is IPC. This isn't performance. Is it?
No, it's instructions per clock. Yes, but this is actually versus Raptor
fixed
Cove,
frequency,
which is not Meteor Lake, the one before that. But it's roughly equivalent.
Also, it's projection / estimates plus minus 10% margin of error. So it's basically saying our E cores are now as performant per clock as the P cores were 2 generations ago, trying to bring up some parity in performance. And then do you have you don't have the E core comparison here?
No, that was 38% on the integer side and 62% on the floating point side, if I remember correctly.
Which are amazing numbers, but again, they compared it to the low power E cores in Meteor Lake, which were on a TSMC N6 process designed to be 2 gigahertz or such.
Yeah.
It's really, they should have done an E-core versus E-core comparison if they wanted to be ideal, but they didn't want to. That's okay, so let's just go on to, let's bring out this picture. Lunar Lake, 4 P cores, 4 E cores, total of 8 threads. We didn't get into the XE2 GPU, the sort of battle mage derivative. The way to describe it,
that's what I'll say.
Yeah, and we already said earlier 67 intake tops in Lunar Lake, so it's good. There's some performance in there. And built on TSMC N3B, packaged at Intel, so it's not fully TSMC. It is packaged at Intel. Which kind of goes towards what Pat says. He doesn't care if you make a chip or package a chip or use an Intel chip, as long as it's one of the 3, right? So it's and as Hayul says, spec requires any result you can't to be marked as estimate anyway. Yeah, it's more the plus minus 10%. I think I was getting at. It's did they disclose the memory capacity?
I think they said up to 32 gigabytes.
Yeah, so that's the one downside of this, is it's not going to have configurable memory. Though we have seen pictures of boards with this, and it is reducing board area because you don't have to have the memory. One thing Intel's doing here is also removing the power delivery on chip, the linear voltage regulators. So now the PMICs are all off chip, which means the chip has to have 4 PMICs, which increases the board area, but overall it's less. So that's interesting. Next, let's talk about the Xeon 6 CPUs. Last thing from Intel. So we saw it earlier that the P core and E cores. Intel gave more flavor on this actually just before Computex. Actually, the way to think about it is that there's actually going to be 4 types of Xeon. There's a 6700 P and E, and the 6900P NE. And the idea is that 6700 is what most people are going to use, and the 6700 people is going to be what most people use. The 6900 is what the higher end will use, and this is where we get 288 E-cores in a dual socket, or you can have 144 cores in a dual socket, or 86 performance cores in an 8 socket. And the whole point is the 6900, it's a bigger socket, higher memory, supports MCR memory with the P cores, more lanes, more UPI links. I think I have another. Yeah. And the SKU list. So at first, we're just going to have the Sierra Forest up to 144 cores launched. So this is 6700P, 6700E, and you can tell by the name 6700E, essentially. And oh, good. This is one slide I told them to change before it went live. They did change it. Hey, something I said made it at least through. And they're E-cores, so obviously 3 gigahertz is still the target. And these are just down bins. They're going to have again the accelerators, this DSA, QAT, DLB. But the difference here is now that they're going to have some SKUs with 2 accelerators and some with 4.
So this is actually a nice change. They're now having all the their DSA, IAA, QAT, and DLB are on all the SKUs, which is a very nice change from how it was prior, where some SKUs would have them all, but some would only have one of the accelerators, and it was a mess. Having them all on all of them is great.
It's because there were like 50 different SKUs depending on what config you wanted.
Yeah.
Now the E-cores, there's literally 7. It's on 6700E. 6900E, they may be different, and then we've also got the P-cores coming later. Increase in TDX keys, that's going to be a value add. No pricing yet, because I'm pretty sure general availability will still be a few months out. They're announcing this now. The 6700P is coming later this year, and the 6900E is coming later this year. I believe a few press have already got hold of these to review them. They seeded Serve the Home, and thanks to Patrick for helping provide this slide, and Phoronix. I'm not sure if anybody else has tested them yet.
I think Storage Review has one.
Oh, Jordan. Yeah, of course he does. That they seeded them to select few, and I'm not in that seeding program anymore. Let's go to, because we are an hour and 12 minutes in, AMD. AMD kind of got, I think after the event, got lost in the weeds in terms of their announcements. A little, because everybody had something big or unique to say, and AMD was like, we've got stuff coming.
Yeah.
Sort of thing. So obviously keynote, and this is the first official keynote. So of course George and I met on the train. We actually stayed at the same hotel this year, didn't we?
Yes.
Yeah. So it turns out $120 a night right next to the convention center, or one stop away. If it was that at CES, it'd be amazing, but it's not. And because this was an official keynote, there's some Teitra stuff. Follow along. Yeah, they said 12,000 professionals and 1,000 journos at the show. I think at the end they said 85,000, so I'm not sure if there were big sign-ups.
Maybe they meant just at that keynote.
No, the keynote wasn't that big.
Ladies and gentlemen, please join me in welcoming Dr. Lisa Su, Chair and CEO of AMD.
Yep, Lisa comes into some fanfare. Most important Computex ever. It's important. It was close.
Yeah.
The only thing missing was a proper desktop CPU launch. But yeah, lots of AI. They even started speaking about Zen 5, and XT and A2. We'll get to that in a second. but their big thing was, new announcements of the Zen 5, the Ryzen AI branding, and new Granite Ridge, not Granite Rapids.
Yeah.
Really annoyed that there's two companies with Granite now. Because they used to, it was like Matisse and Zeppelin and Renoir. And
so if you go back, there was Raven Ridge, and so
no, but
I don't know why
they
went back to the Ridge. I don't know.
Zen 5 is meant to be a complete rewrite of the core architecture. So it could be a different team building it. That might be why. But Zen 5, just like AMD said, Zen 4 will be everywhere. Zen 5 is meant to be everywhere. It's an 8-core CCX, as before, as shown by this mock-up.
Slight correction. That's for the desktop chip.
The
server version, that we'll get to, has a 16-core CCX, and it's one big. It's 16 cores on the same. It's not like Bergamo where you had essentially two.
The Zen 5C one.
Zen 5C is one 16-core CCX.
Yep.
Okay. I think the most interesting thing on that slide, just slightly above.
Yep.
Parallel dual pipe front end. What is this sort of back to Steamroller? Because Steamroller had two decode clusters, and sort of two front ends. I'm wondering if they went back to that.
No, it just sounds like just dual branch predictors.
But to some degree, you already had that. Like,
I know.
Yeah, so we need more information when that comes.
Yeah, it's at some point there will be a deeper disclosure. This wasn't it, by the way, but are saying 16% IPC uplift. Normally, AMD's IPC numbers are conservative. Historically, if I was to point out one company that's got their IPC numbers either bang on or just below what we actually test, AMD's been pretty consistent over the years. But 2x AI performance.
So fun thing, that's the first time they've increased instruction bandwidth since, I believe, K8, if memory serves. Just a fun fact.
Yeah. And this will be the high-end desktop chip, 9950X. So all the 9s. So it will probably be $999.50 if marketing get an idea. 16 cores, 32 threads, 170 watt TDP, and they do this combined L2 and L3 cache. That's 16 plus 64. And then, there's Lisa holding the chip. The dies, the CPU chiplets are more square. Mm-hmm. So it's worth noting. I caught an odd picture on the slides before they went live, because again, disclosure, AMD's a client of mine. But it's all good. They also, so that was that it for like Zen? No, okay. So
that was it for desktop Zen 5 for the most part.
Yeah. They're committing to more chips on AM4, and then AM5 will be committed to 2027 plus. So people are always wondering about AM5. Will it be longer support than what was initially announced? Because they only committed to like 2 generations of CPUs initially. Now they're saying it'll be another 3 years from today. It'll still be supported. So these chips are coming in July. This is Zen 5 on AM5. Up to 5.7 gigahertz, 16, 12, 8, and 6. As you perhaps might expect, no non-X's to begin with. These will all be overclocking SKUs, DDR5 support. Mm-hmm. More details to come. And this is an official keynote, so we had to go through pretty fast. Now we go on to mobile or notebook. So Ryzen AI, the new branding for Strix Point, coming to notebooks, still monolithic, Ryzen AI 300 series. This will be what will be in the AI Copilot PCs. So this is, I wonder if this will screw up or not. Will this work? Okay, yeah. So 50 tops NPU, up to 12 cores. That'll be is it 4 plus 8?
It's 4 Zen 5 cores and 8 Zen 5C cores.
We'll get to that in a second, but also updated graphics. Not a full update, but still enough to warrant a 0.5. And then the flagship will be the HX 370. And I've seen a lot of people get annoyed with this name. So there'll be Ryzen AI 9, Ryzen AI 7, Ryzen AI 5, but the top of the 9 stack will also have HX initially. And then 370, because they're calling it their 3rd gen NPU, because they've technically had 2 generations with NPU in, but it's not been that accessible. This is the first accessible one, but it's technically their 3rd product family with it. So that's why they're calling it 3rd gen. Also HX 170 was a taken product name.
Yeah.
Already.
Nvidia, I believe, had a
mining
cut-down,
GPUs.
Yeah, A100 mining GPU that was called HX 170.
Yeah. So, just to pinpoint here, AI PC is just a scam. If you don't like AI PC, you don't have to use it. The NPU is optional, as in none of your software has to use it if you don't want it to. Just like the GPU, you don't have to use the GPU if you don't want to. You still get the CPU bar. So if you don't like AI, just ignore it. And let me scroll the right window. So next generation AI engines. Sorry, my scroll wheel's being a bit weird. So previous XDNA 1 was a 4x5 tile. This is an 8x5. Though the capability of each tile has also improved. That's where we're going from, 13 tops to 50 tops, or 10 tops to 50 tops, whatever it is.
It's 6. So it's on Phoenix, it's 10. On Hawkpoint, it's 16.
Yeah. Okay.
Yeah.
So this does come from the Xilinx acquisition. It's using the AI engine ML design, which there are documentation you can go look at for that, but it is slightly different in terms of what number types they support. I haven't had a clear answer on it, but AIEML, if you do a search for that, you'll find some details. And one big thing I thought was huge, though AMD may not be unique in this generation of announcements, is this support for block float. I have a video on Nvidia Blackwell supporting block float.
So block float, what's interesting is that this is block FP16, which there is no official spec for.
There's no official spec for most of these FP8.
So at least with block float, there's the OCP spec, right?
So the one that most people are familiar with, and the one that Nvidia supports, is a 4+8. So 4-bit performance with 8-bit accuracy, essentially, right? AMD saying here that they can do 8-bit, 8+16, which is still half the performance of 4-bit, but better accuracy. The thing is, I spoke to some engineers, and a lot of them say we can do it, but it's not natively supported. AMD here is saying it's now natively supported, and that takes effort. So,
yeah. Again, questions will have to be asked about what exactly this is.
And it's annoying that the state of AI benchmarking is actually really bad right now, because everybody uses a different API and software stack, that it makes testing difficult. So as I said, it's not MXFP12. This would technically be MXFP24 by the same naming. And then also we have to, because AI Copilot Plus, we can go into that.
We call
Copilot. And they've recalled Recall since then. But AMD is integrated with 150 ISVs. That's independent software vendors. HP was at the stage at most of these. And then we went into some performance numbers against is that estimated Snapdragon X Elite numbers?
Yeah, that's X Elite. That's M1.
M3.
Oh, sorry, M3. Excuse me. And then that's Meteor Lake.
Yeah,
I think that's either 18.5H or 15.5H. I don't remember.
everybody likes to pick and choose the benchmarks that make them see the most. So Asus to the stage again. And there were a good number, I think, of these Ryzen AI 300 notebooks at all the vendors.
Yeah, there were. There were quite a few.
This is just Asus. Yeah, we saw HP, Lenovo, MSI, Acer as well.
AMD's sort of weak point in the laptop space has been they've announced a chip, and then you wait and you wait and you wait, and then it finally launches.
Yeah.
Hopefully, Strix will. They've announced it, and it will come when it actually is supposed to come. Hopefully, that is.
Yeah, it's the first devices are meant to be available this month, though. I think pretty much back to school is more the sort of interface. Maybe, again, they say 100 platforms. That'll be 100 platforms for the rest of the year, maybe even into Q5. So, yeah, they're also speaking about their embedded stuff. Again, coming from the Xilinx group, they've got an all-in-one Versal AI Edge 2. This is about reducing AI complexity in the embedded space. And then we move on to data center. This is where AMD EPYC is the #1 CPU for hyperscalers. That doesn't state whether it was the #1 hyperscaler CPU, which I wrote up here, or it's the #1 choice, because that is a subjective measure. But what they're saying is that, the question has always been with the EPYC line, how much market share can they realistically get? And it turns out they're saying they've gone over 30% now, and it's more than 50% in hyperscalers, and in certain ones it's even more than 50%, because in order to have an average of 50% means you're going to have some above and some below. And then the same argument versus Intel, the 4 or 5 year update cycle. And then this is the Turin. This is the
what's interesting is that they did not. So we know that there's 2 chips. But they're calling this Turin when this is actually the Zen 5C die with 190 or
it's the Turin family in the same way that we had the Genoa family.
Yeah. So this is Zen 5C, but we also know that there's a 128 core version of Turin with the regular Zen 5 core, and that maxes out at 128 cores.
But you can see in this picture there are 12 chiplet dies plus a central I/O die, following your AMD strategy when it comes to server.
They're very long dies, by the way, even in person.
Yeah. Early AI performance numbers. I think this is the one that got. These are the ones that Intel got really. There was this back and forth. Intel saying AMD didn't run it properly. AMD said we did.
It was specifically, I think, the chatbot.
Intel basically ran optimized versions of this, and they beat AMD in one and became just behind in the other 2. And one of the arguments, as always with AI testing, is: are you running what people can go out and just deploy today, or are you running software that is optimized to the nth degree? So there's been a bit of back and forth about this, about whether you can believe these numbers. These are all first-party numbers. Don't believe them. Wait until our testing. We can all go ooh, but that's about it. And Turin coming second half of the year. And now for the AI chip, Mi300X. This is what AMD says is going to be like $4.5 billion revenue by the end of the year. Putting out the same numbers they did before on training and inference.
New numbers. These were throughput numbers.
The inference against Nvidia H100.
Yes.
Partnership with Stability AI, public access, and a roadmap. So we had the Mi300X. That's what, and we'll actually go to an article because George has been testing one. That's with HBM3. There's going to be a version with HBM3E, so more capacity and more bandwidth. Mi350, which is the CDNA 4, so new architecture, and then the Mi400 again, a new architecture. So this is the annual cadence. We'll get into some of this in a second. We'll get into it in a second. And yeah, numbers here. Mi325, same as 300X, just more memory, more faster memory. And then advantages versus H200, because everybody needs a high capacity memory version. And then the next year one, 3 nanometers, this FP4, FP6, same as Nvidia Blackwell. Available 2025, same as Blackwell. And then, yeah, some performance numbers, gen on gen. Memory capacity, that's a very fun graph. And then onto UA Link. We've covered UA Link a bit already, but you know, as George said, it's coming from the Infinity Fabric. Ultra Ethernet, again, you know, everybody's playing. And this is how, you know, AMD sees the scale out. Same with Nvidia. You know, all the disclosures. So 9000 series available soon, July. AI PC 3rd gen, July. AI Edge Gen 2 from Versal, that's their embedded stuff, early access now. You know, that's long life cycle stuff anyway. Then Turin, second half, and then the HBM3 accelerator in Q4. For anybody wondering about the $4.5 billion in AI revenue, AMD was saying, that includes the Mi325X. That was already baked into those numbers. And that's a wrap for the keynote.
Would just go back up to the so think of the people have been debating about the naming scheme of Mi300, 325, and 350. Just think of it as sort of a socket, right? Think of it as a platform family, not as a chip family.
Yeah.
Or architecture family.
Yeah. They're being a bit loose.
Well, Mi300, Mi325, and Mi350 all sort of fit into the OAM form factor, which implies that Mi400 will not. So how that changes, we'll have to see.
This is my article on the 325X announcement. Pretty much going over the same thing. To be honest, I think it's going to be essentially memory architecture, because people, will eventually get to 1 terabyte of memory on these things, and then support for 6 and 4-bit. Don't get me started on 2-bit. This is my video on microscaling. Updates to ROCm version 6.1. Again, it still needs to tighten up.
So actually, something that AMD did not go over in the keynote, but they did have a press slide for, was that ROCm is coming to WSL, which is a nice.
WSL, for people who don't know, is
Windows subsystem for Linux.
So that's if you want to.
Basically, you can run Linux on Windows.
Yeah. And then you had a chance to test Mi300X.
Yes.
In a big article that caused Tom's hardware a lot of headaches. That's interesting. We won't go into any salacious details here. Let's just say the people usually editing Tom's hardware news articles were on holiday, and so something got out that was quite almost defamatory.
But anyway, so talking about the chip itself, it puts up some very, very impressive numbers. So this is all the cache latency and bandwidth.
So go over what your experience was testing it.
So what I can say is that going from Mi200, specifically Mi210 to Mi300X, with regards to the ROCm stack, it's night and day. Like, it's improved so much in the 12 months. there is still work to be done. Do not get me wrong, and we go over that in the final words. But there have been some major improvements, and for the most part, actually, basically for all of it, it just works. That sort of saying. For us, it just sort of worked, which is very nice. There were a couple snags, but those were more us not knowing quite what we're doing on the ML side, so we had to fix that. Just sort of.
How many days did you have with it?
We had 2 weeks. But
and this is an unpaid 2 weeks. I might add.
And we would like to thank the folks at Hot Isle, John and
Elio
at Hot Isle, and Elio at Elio VP and Nscale for helping us with the tuning of the LM benchmark, since we don't really know what we're doing.
But it's I highly suggest going to the Chips and Cheese article. The one question you might ask is, well, where's the latest Nvidia numbers? There are some Nvidia numbers, but these guys only get the system, as he said, for 2 weeks, right? And when they had the Nvidia stuff, that was ages ago. Chips and Cheese isn't on the radar enough to have permanent access. Which is a shame. These systems, though, are expensive to have permanent access. But the bottom line here from the AMD testing is that AMD is competitive. One thing that, and I'm going through this fairly quickly again, go read, is that Microsoft have said that AMD Mi300X is cheaper for ChatGPT inference, dollars per token, token per watt, performance per watt, is significantly cheaper than Nvidia. So maybe it's a situation where Nvidia's great at training and AMD is great at inference, because at the end of the day, training is making all the money now. Inference is likely to make the money in the future, but you know that both companies are going to make products for both markets. I am saying to AMD, keep plugging the fact that your customers are saying that you're cheaper than Nvidia for large language model inference, because that's a massive win if you end up cheaper than Nvidia, and you can offer it in volume. There was a discussion, people saying that the lead time for ordering AMD is half or less than half than that of Nvidia. If you order Nvidia today, you're waiting at least 52, maybe 57 weeks. Whereas AMD, if you put in an order, you can be as low as 20, depending on how much you want to overpay. So,
I think that second to last paragraph really does sum it up, right? It's a very impressive piece of hardware, but the software does need to sort of get there. And like I said, in the past 12 months, it's improved significantly.
If anybody who has access to NVIDIA systems and would like to donate some time, of course, comparative numbers.
Comparative numbers are always great, but sometimes it's hard to get stuff. But no, they're like I've said, there's been.
So Mark, thank you for the Canadian 5 again. Thank you. George Hotz, and we all know George.
Not me.
Says AMD. Well, we know of George. Says AMD isn't competitive when it comes to the software stack. I think from what you've said, it's getting better. I've spoken to companies like Lam and I who said, it used to be really rough. It is getting better. It's a function of time and developers. The question is whether you want it now or whether you want it in 6 months.
And what I'll say is that AMD has been putting forward some LLVM patches that show that they're adding what's known as intermediate representation language.
MLIR.
SPIR-V between their assembly and the
Yeah.
ROCm stack, which should help with the sort of compiled runs one anywhere. That Nvidia has gotten right, because you pick up any Nvidia card and it will run CUDA. Hopefully, near into the future, that will be the same for AMD.
So
we did get a quote from Lisa on that. So hopefully that's sooner rather than later.
Yeah, it's so Spear V is an MLIR, mid-layer interpreted language.
So MLIR is a specific thing.
Really, I thought it was a colloquial name for a layer.
No, MLIR is its own intermediate language.
Okay.
Yeah,
that's I missed that Hot Chips talk. I think I was flying in that day.
So
let's move on. AMD done. Now let's time AI PC. George has one on hand. The Samsung Book 4. We'll get to that in a second, but let's just go over what Qualcomm announced, because they are the lead partner with Microsoft for Copilot Plus PCs. ARM-based Orion chip derived from the people that came from the Nvidia acquisition. They built this new core for Qualcomm. And yeah, again, an official keynote. The only company that didn't have an official keynote was Nvidia, because they had the only official keynote last year out of all these companies. So Qualcomm laying it thick that the next generation of PCs needs to be AI. Cristiano is very adamant that this is the future. And to be honest, all the companies are following him, right? They just happen to be the first out of the gate with Microsoft as the lead partner. The benefit being they don't have the legacy of x86. The downside being they have to cater for all the x86 stuff despite not being x86. We'll get into that in a second. But Cristiano's CEO saying as big to personal computing as Windows 95. Debates in the comments. But yeah, the whole industry is changing to what X Elite and Copilot Plus can do. They are setting a benchmark that everybody else has to follow down the pipe. Whether it's AI, whether it's things like battery life, whether it's things like performance. It's all about what do we want in a device next. And you can poo-poo AI, and plenty of people have poo-pooed AI, and I'll say poo-poo again to get my poo-poo count up. But GPUs, right? How long did it take for GPUs to become a standard thing that wasn't just simply a 2D display out in a notebook? NPUs are here to stay. So if they can accelerate specific workloads, if they can, AI has two dimensions. One, what can it do better that we do today? And two, what can it enable that it doesn't do now? We're in that stage now where everybody, it's almost chicken and egg, even though the answer to that is always egg. Right? It's hardware and software. Hardware is now here. Software is rising to match. And that's what everybody is getting lots of money to do. That's where all this, all the development effort is going. So all these new possibilities and things like security and developer innovation and multi-day battery life, we'll get into that. But the big announcement is, so that's your first Snapdragon device, isn't it, George?
Yes.
So I've got a
laptop. Snapdragon
first laptop. Yeah. I've got a Snapdragon 950, which I think was their 3rd generation, and this is their 7th generation, technically.
I think you mean 850.
850, yes. Sorry. Yeah. But if I add up the 1st to the 6th generation, all the SKUs, I think I get a number of like 12. So the fact that they've got 22 launch devices for this generation means it's bigger than ever for Qualcomm.
Yes.
And how long did it take for AMD to get premium devices for Ryzen? It wasn't until Zen 3, really Zen 3 Plus.
Yeah, Renoir moving into Phoenix.
Yeah. So right now, Qualcomm is, as the lead partner with Microsoft for Copilot Plus, is being able to get into all these devices now and start those conversations. It's going to be coming to things like a mini PC. We really wish at launch day there'd been mini PCs. tablets, and all-in-ones. The idea it's going to come. It's going to come. And then, redefining Windows with this high-performance ARM core. Satya turns up again because he has to. And then one thing Qualcomm gets a lot of credit for showcasing a lot of use cases that AI could potentially do in the future. A lot of them, some of them were real demos, some of them were mock-ups. But it did go to show some of the ways in which some people are thinking about how to use AI in device. They're not there yet in all situations, and arguably you might say 5 years down the line, we're less than 1% of what we can do with machine learning today. But it all derives from the fact that Qualcomm has had an NPU in its chips for multiple generations. They used to be called a DSP. Do you remember Hexagon DSP?
Mm-hmm.
Qualcomm did a good job in actually deep diving into their Hexagon NPU just before Computex, and then also into their CPU and GPU, which we've got to give them the credit for. Qualcomm, traditionally a very conservative company.
Mm-hmm.
They opened up fully on CPU and GPU.
It was very nice that they
they deserve more credit for coming out of the gate with that. I mean, to be honest, it's something we've been going at them for a while for, but when they finally did it, they did it properly.
Yeah. Mm-hmm.
Some minor adjustments on the CPU side. I think I preferred more detailed diagrams, but GPU side was amazing. They brought out Eric demos. And for those of you who don't know, Adreno is an anagram of Radeon. That's where the team comes from. So NPU is Snapdragon X Elite 45 tops against the 48, the 50s of the others. Basically anything above 40 now gets the Copilot Plus brand. But the big thing here for Qualcomm is performance per watt. So they're saying at their most efficient, they can do multiples of what the competition can do with what the competition had in the market at the time, right? Since then, M4 has been released, and Intel's spoken about Lunar Lake. This is about what people can test. And our good friend Andre made these numbers. So you can tell that you can guarantee that he wouldn't have put out benchmarks that couldn't be replicated. And we'll get into that in a second. Thermals, this is 1 hour NPU usage, 20 degrees difference against Intel. Microsoft, these were Cristiano's shoes. I love these shoes. They've got the Copilot Plus logo on. I want a pair. Microsoft leading with the Surface laptop and the Surface Pro. They're the lead Snapdragon devices. These performance versus power, single-threaded against the competition. Again, Andre generated numbers with some fine print, of course. And then top-line numbers. My cat's trying to get out the door. Against NPUs. Again, this is against stuff that they can test now, not against what people have announced in the future. You can't test against stuff that hasn't been released. Battery life. We'll get into the battery life in a second. This is against Intel. Acer, so 26 hours. Each company was trying to up themselves. 26, 27, 28. It was funny. And then they made a big thing about all the different apps you can use that are now optimized for Windows on Snapdragon, Windows on ARM, whatever you want to call it. I think the headline they said is, based on the research done by third parties, 90% of all the hours used on a PC are now ARM native. They now have ARM native versions for those apps. So it's not a number saying 90% of all apps, but 90% of the time used on a PC will be with the ARM native applications, rather than translated, emulated versions. Web browsing speed, again, native software compare versus Intel and AMD. Music instrument demo. Basically, can you take out instruments? Not sure if this will load, actually. and we all know how good machine learning has been for noise cancellation, noise isolation. Now you can do it with music, not generating, but just isolating. So as a DJ, you can mix and match as you need to. This is just one of their partners. HP to the stage again. Developers. Good old Bournemouth throwback. Qualcomm AI Hub. So they've got pre-trained, pre-optimized AI models. This is you need to go check the AI Hub out. It's all pretty much GitHub pulls, so you can run it. I'm not sure if you had a chance to look at it, George, yet.
Not yet. I haven't.
Yeah, it has like versions of Whisper and some Stable Diffusion. They do need to put in, Llama 3. I think there's a Llama 2 version in there. This is going to be stuff that they're going to be adding to over time. And so this is the dev kit. This is the, thermally unlimited version that we all want. Pre-order today, available on June 18th. I put my name down at the keynote and got an email on June 18th saying, demand has been so high, you have to wait a bit. Did we get a price on this? $699?
It's either $699 or $799.
But it's the top end SKU with the most memory, we think. So many thanks to Phil for the $4.99 with the kitty. Hope you have fun. Yeah, I know we've gone a long time. We've still got some more to go.
Yeah.
It's all fun. And then Delta stage again, more partners. I think they had more partners than anybody else because they wanted to showcase that they had so many systems.
Yeah.
Snapdragon features like Wi-Fi 7. The standard stuff you get on the smartphones. George hasn't had fun with Wi-Fi 7. Let's just put it that way. Optimization. We'll get there. The gaming. Now, this is the issue, right? A lot of people were interested in testing it for gaming because Snapdragon is about gaming, right? Well, gaming on Windows is a different beast. They say 1,200 games work. Performance is still, debating whether 1% lows versus average is the right frame rate to start talking about. And the point is, these aren't meant to be gaming systems, but you should be able to do some light esports gaming with it. We'll say more into it in a time. Yeah, devices in hand, June 18th. Retailers. I was in Romania at the time. I asked at the shop, and they said the shipments to Romania have had a 1-month delay. So I couldn't buy one. George got one day one.
Yes.
And that's the keynote. So you went out to Best Buy.
Yes. The Chips and Cheese Patreon funded this.
Yeah. So if you go donate, if you become a Patreon of Chips and Cheese, it means that they can buy hardware that they haven't been sampled.
Yes.
The sampling for these devices was Microsoft/OEM led, not Qualcomm led. And I know that Asus had a big problem with their shipping. They somebody made a digit error, and I think they put 8 rather than 800 samples. Or it was perhaps more, they got 20 and they were thinking of sampling 200. So second batch is going to have all the units. So I didn't get a unit. George didn't get a unit, but George went out and bought one. Book 4, you got the mid SKU.
So this is technically so they only have 2 SKUs. You can either get the X.
No. So out of all the X Elite SKUs.
This is technically
the 80.
This is the 80, which is the mid SKU that you can buy in a laptop. The dev kit has a slightly higher SKU with 100 megahertz higher boost clock, but other than that dev kit, this is the mid range SKU.
Yeah. So inside the chip is 12 Orion cores coming from the Nvidia acquisition. That team develops these new cores. Adreno X1 graphics, the onboard NPU, because George is almost finished with testing, I don't want to give what he's discovered away, because he's shown me some of the numbers and they're really interesting for the article. The one thing, so I do want to talk about some of the responses in the reviews we saw, because we saw a wide range of, this is amazing to I don't want to buy this. And it really seemed to depend on whether people, what SKU people got, what design, but also whether they felt they were testing the notebook or the chip, right? And so as a result, we got some people saying, this is amazing. The standby battery life is amazing. Now, this is something that Qualcomm's had for multiple generations anyway, but for a lot of people, this is the first time experiencing the fact that you can put a system to sleep, leave it for a week, and you still have X minus 2% battery. Any x86 design you put into sleep, you have lost your battery within 3 days, pretty much, right?
So, okay, now this might just be my experience, but at least with Tiger Lake and my Phoenix laptop, I had a Tiger Lake laptop for the lab. Those actually have functional sleep, which is shocking, I know.
It's
very designed to design. From what I know of X-Elite, that is not the case. It's basically universal, which is very, very nice. Yeah.
And one thing we have to realize is that when Qualcomm puts out all these numbers, in performance and whatever, a lot of them, they're looking at peak versus peak, right? And we, when Qualcomm has shown numbers off in the past, because they didn't allow pre-testing, and I think that was a Microsoft requirement. The samples are actually meant to come out a week earlier for testing, but because of a OS issue, Microsoft stopped everybody from sampling early. So it was more software driven. But a lot of these numbers, looking for peak, no one SKU that was launched on day one was a peak SKU.
Yeah.
It's the way to look at it is Qualcomm showed off two reference designs, even back in November last year, a 23-watt device and an 80-watt device. Most devices that came out, even yours, George, is somewhere between 20 and 45 watts.
So this can just about do 50 watts from the battery power draw.
And is that peak is that peak initial or is that sustained?
That's sustained. I can get it up to 55 if I put this right on top of my AC unit right here.
Yeah. Okay.
But
so
this is I can't get it any higher.
Which means that performance will be muted somewhat versus the peak results, right? And I don't think people were expecting that. Because normally with a launch, I have some Zephyrus G16s or G14s, whatever, from AMD, and it's usually the top SKU in a thermally sufficient package. Now, laptop vendors, when they design a SKU, they design for a given power range and thermals. So even if you have a bigger device, if Samsung say that device limited the max skin temperature to 55 degrees, max internal temperature is 70. If a smaller device goes to 75, it may perform better. And you're thinking, why is a smaller device performing better? Because the design point, right? And I think a lot of people still in the notebook space don't understand that notebooks are it depends a lot on what the vendor wants to hit with their design choice. And maybe that's a customer-driven B2B product. Maybe it's specifically for the consumer market. And as a result, we saw a lot of negativity. Now, I'll preface this by saying I haven't tested it yet. George has. George agrees with some of the negativity and disagrees with some other parts. So again, I'll wait for his review. But notebooks are a spectrum of performance. And what I want to see is somebody testing 5 different SKUs, then also 5 versions of the same SKU. to account for binning variation, because this is Qualcomm's first attempt at volume notebook stuff. So there are going to be things that the other guys have ironed out that Qualcomm needs to work on. George is pondering exactly how many of those things need to be worked on.
Well, it's more so.
I really wish everybody had had a reference device.
Yes,
Qualcomm do a good job in smartphone is the fact that they offer a reference device before launch, and people get anywhere between like 2 and whatever hours to test it. So at least they have something, and that number usually bears out over time. Unfortunately, I think due to the way that Microsoft were keeping things so close to the chest, and Microsoft is more concerned about the software, right? So the fact that the OS wasn't ready and things like recall had to be taken out means that Qualcomm couldn't seed reference devices because Microsoft wouldn't let them, or at least this is the opinion I get. At least with a reference device smartphone, Qualcomm is in charge of the hardware and the software. In this case, they weren't. So all the issues about gaming not working or drivers not working and things like software not working because of the emulation, functional stuff will get ironed out over time. And
now,
I don't see people necessarily going out and buying these day one.
So I'm going to preface this by saying this has nothing to do with the X-Elite chip, but with the platform. And I have had no ends of issues with the Wi-Fi chip, the Fast Connect 7800. So,
you're having a purely functional issue, the fact that it's kicking stuff off your network.
Well, it's kicking stuff off the network. And it actually brought down... So I actually connected this to my main desktop over a hotspotting. It brought down my main desktop's internet. I had to reset the entire system to get it back.
Yeah,
So I don't know what's going on with this chip, or I don't know if it's just this one sample. Maybe it is, because I haven't seen any other reports. But
is it a Samsung issue? Misconfigured driver?
it might. I can't tell. I only have the one device.
So this is also going to be another thing that's going to bite Qualcomm on the butt, because these are OEM laptops. Whenever Intel, AMD, Qualcomm, whatever, have a driver update, the OEM has to validate the update before they push it out to customers. So we're going to have devices over the next few months. Some will be on the latest update, some will be on N-1, some will be on N-2. And the reason that, say, HP has to validate it is because if they have business customers, they need to go to the business customers and say, this update doesn't break anything.
Yeah.
They'll have to make sure that it only goes forward. And with notebooks like this, there's no beta channel. So there's, even if you wanted to be on the bleeding edge to make sure you get the update, because I know for a certain fact that George definitely wants a new Wi-Fi driver, regardless.
Yes.
But he's going to have to wait until Samsung validates it. He can't go to Qualcomm and download it.
Well, okay. So again, in our testing, we tried to. So this has the May 17th GPU driver version. I can't remember what. I'll figure
There's
out.
a new one coming.
So they released a new driver on the 10th, and I tried installing that driver to this system. That broke the system, and I was forced to roll back that driver.
Yeah,
and I think this is something that's on Qualcomm here. Their GPU driver update system is basically non-existent. So, like with AMD, Intel, Nvidia, you have a control panel. Now, Qualcomm has said that this is coming.
Yep.
But this is something that, in my opinion, should have been. Sorry, Dom. But this is something that should have been day of launch. Is that there should have been a control panel for Arduino so that you can update drivers.
The way I see it is almost like Intel's GPU drivers. Over time, they've gotten massively better for Alchemist. You remember day one, Alchemist had issues.
Oh, yeah.
Some games didn't work. Their DirectX 9 stuff wasn't properly. But now, in some games they're 300% faster
So
than they were. I
my
think
issue
Qualcomm is
not-
going to go down that road.
But my issue is with the actual updating of the driver. With Intel, with
actually how to
AMD,
update.
with Nvidia, you can go into the control panel and download the newest driver, or you can go to this report page and download the newest driver. That is not the case with Qualcomm right now. They've said that it's coming, but in my opinion, that control panel should have been a day one software stack.
Yeah, it's because I think Qualcomm, in order to get the 22 wins, design wins, they've had to, basically adhere to people's requests. And one of the requests may be, let us deal with the driver updates for our clients. You sit back. And that's perhaps something they've had to concede. That will probably change over time as the other.
So I'm going to disagree with you on that. And so Casual in the chat says, product launches are never perfect. They will get there. Drivers will come. Yes, I agree. However, this is not Qualcomm's first chip on Windows.
No.
This was something that has been requested for a long time. And in my opinion, they should have known about updating drivers a long time ago, especially GPU drivers. So this, I will point to Qualcomm and say, you could have done this better. My opinion, but...
Yeah. It's... I think we'll leave it there because we have been going on 2 hours. I do want to at least cover one more thing. And I think let's start with this. This is Nvidia's GB200, Grace Blackwell 200, the most expensive GPU in the world. I was not chased. It's a small little fun thing. So Nvidia didn't have the official keynote, so decided to go into a stadium instead. Did you end up going?
No, I didn't.
Yeah, it's I was busy that evening, and I asked Dom, my cameraman, to go. We let's bring up most of the announcements were enterprise. Can I do this? There we go. So there was a keynote, there was a Q&A. Lots of people asking about HBM, a lot of people asking about Foundry. Jensen's basically saying we now make AI factories, not chips. He was asked about UA Link. Nothing about 50 series. If people are expecting it this year, I don't think it's going to come this year because they're too busy building as many Blackwells as they can to sell. And that's what I had in my hand in that clip, Blackwell. So yeah. And again, it's AI. It's talking about how moving to a yearly cadence. The same thing with AMD, memory architecture. No real talk about extending chiplets, but and their approach to AI PC was basically, well, people have RTX. RTX does AI. What are you complaining about? On the efficiency side, he did say we do race to sleep, which is a funny Intel circa 2014 argument. Mm-hmm. This question was funny. Who is your enemy?
Mm.
Nvidia is so likable. We're so adorable. Why would anyone want to attack us? Well, you got 95% of the market, mate.
Mm.
It's a lot of money. Kudos. But yeah. This will be on the more. You can read through. We're going to actually do some shorts on this. So people who consume information via shorts, we're going to do some based on this. But yeah, Jensen saying he didn't speak about gaming because his keynote was 2 hours. Bearing in mind, his keynote was twice as long as everybody else's, and he still didn't talk about gaming. So it's There was a time in the past where Nvidia's keynote was proportional to the stock price. I'm glad that's no longer the case. Otherwise, it would have been 6-7 hours. So yeah, go check it out. It's free to read on the More blog. And yeah, I got a chance to actually play with NVIDIA Ace. There's a video that's still in the works to do that. That's their AI for games, interacting with NPCs, built on AI. That was really fun. I managed to get an AI, the one that was like a bellhop, talking about what cheese is best to paint your walls with. And then later in the conversation, he re-referenced cheese. After talking about how do we bludgeon guests we don't like with luggage, he then spoke about cheese. Just prompted out of nothing. So the fact that he remembered was fun. Yeah, and we still have to go through the content of that. The last one I wanted to speak about today is the Samsung Foundry Forum. So this is Samsung's first more sort of press public forum that they've done in person since the pandemic. Now, prior to the pandemic, they were talking about actually visiting the fabs in person in Korea, and then the pandemic happened. And I'm really hoping we get to a position where they can do that again, because that'd be fun. But I managed to get into the official photos of the event. That's me, you know. Do you know who this guy is?
ARM CEO.
Yes, that's the ARM CEO.
Yeah. Rene Haas.
Rene. The funny thing is, my only interactions with him in person is to take selfies. They also had a presentation at Computex that for some reason I wasn't invited to, but whatever. I also met up with this guy.
Jonathan
Do you know who
Ross,
this guy is?
Grok.
This is John Ross from Grok. This is an AI chip company. They're using Samsung 4nm on their next generation chip. I did take a bite of this chip. It's actually this token here. It's their promise to 25 million tokens per second eventually. It says Grok on it. Yeah, this is like maybe you're too young, George, but if I said Pogs to you.
Okay, I do know what Pogs are.
This is the ultimate slammer because it's weighty. And John is of that generation as well. He also now dresses up nice, the fact that he's got investors to go after. But ARM and Grok did a presentation. Samsung spoke about their foundry lines. So they've got a line in Austin, Texas, and Taylor's the new one. Space for 10 fabs. 4 fabs are announced, and it will be leading edge, and there will be some packaging. Manufacturing. So they've taken some of the old process node names out and put some new in. So do you remember that Samsung used to be like 7LPP, 7LPE?
Yes.
So that's all gone now. It's all SF for Samsung Foundry, then a number, then the derivative. So in the land of Samsung 4nm, we've got the early one, we've got the standard, we've got a performance for smartphone, we've got a performance for HPC AI Extreme, then we've got automotive, and then this U version is going to be like a more, it's basically X but cost optimized, right? So it's like an X plus basically. And then after that, we've got this gate all around. Samsung first to market with gate all around, though not in anything that's actually been launched. It's been more of an internal node, or it's been embedded. But it's this line. So what used to be, they used to have like an SF3B or something, or SF2. It's changed now. So now we have SF3 is going to be like their first public generation of gate all around, then SF2. And the key one here is SF2Z or Z. That's going to be with backside power delivery. So there's variants coming in. So 2027, I think Intel's still planning 2025 end of or beginning of 26.
Sometime around there, yeah.
Mass volume versus general availability is, different.
Yeah.
And then also they started talking about, beyond, the 2 nanometer. So this is, 14A equivalent sort of thing. But that's going to be like their 3rd generation gate all around stuff. They had a bit of the day that was not under NDA and a bit of the day that was under NDA. The bit of the day that was under NDA had all the fun numbers in, but I can't tell you about them. They also spoke a bit about memory. So talking about HBM4 timeframes, but also LPDDR6, and then LPCAM, and then even 5x with this processing in memory. So this is the having some compute in your memory so it doesn't waste as much power. They also, so 2028 for HBM4E. So as high yield
2026 for HBM4.
Yeah. So SF3E has been in production for a while now. That's below complexity chips and low volume. That's the 1st generation gate all around. But back to HBM, they're planning gen on gen improvements, and then they even gave some numbers for HBM4. So pin speed goes down, but with HBM4, data width doubles. So instead of 1024-bit, it's now 2048-bit. And this is due to them doing hybrid bonding, this hybrid integration. So instead of, standard solderable stuff, it's actually going to be, like Vcache, essentially. Whatever they call it, Foveros Omni, the Intel version of that. Yeah. So also the base die is important with HBM, the bit that does compute for the memory. This isn't compute in memory. This is just the management side. That's moving to FinFET for the first time. So there'll be benefits therein.
Now, what's interesting is, so real quick on the pin speed, when I was at ISC, which unfortunately you couldn't go, I was talking with Samsung because they were there, and they said 4 gigabits per pin, starting with their first sort of generation. So keeping bandwidth constant.
Yeah.
And then their second, they were saying that they were going to quickly follow up with 6 and 8 and continue from there.
Yeah. So yeah, that what was presented said 6. So, excuse me, maybe 4 was just
internal.
They also said about packaging. They're doing improvements in the smartphone packaging because Samsung's popular smartphone process node for the mid-range, improving thermal resistance. But also on the AI side, they're looking at what everybody else is doing and having this 2.5D interposer, multiple HBMs. TSMC talks about reticle size increases. But it's interesting here. They're talking about what an AI chip can do in 2026 and 2027. So they're saying in 2026 we're going to have chips with 576 gigabytes of memory. So that's 288 times 2. Using HBM4. So you have a bandwidth of 30.7 terabytes per second, up from 6 terabytes per second with MI2 325X. And then that doubles again essentially in 2027. So this is side-by-side packaging plus on chip-on-chip packaging. But then not only that, imagine taping 2 MI300Xs or two Blackwells together.
That would be fun.
And that's with electrical. Imagine if it was all optical.
God.
Yeah, okay.
That's
boy. Another angle. But yeah, they're talking about which process nodes can be on top and bottom die in what years as well. They also had co-packaged optics. This is all about chip-to-chip communication, but built into the chip, not just networking. But yeah, it was a nice event. It was good to see Samsung coming forward with a unified messaging strategy, right? Because previously, at least in my mind, it had been bits here and bits there. Pandemic didn't really help. This, just like Intel's Foundry event in February, this was a chance for them to go stake in the sand. right? This is what we're doing, and this is our timeline. Now, you could argue they weren't explicit in whether the stuff was like Q1 or Q4, you know, which is something that other foundries tend to do. But they were consistent in not doing that.
Yeah,
it's annoying when a company's like, it's like they talk about quarters one bit and then halves and then years.
Yeah.
Whereas, so Samsung's getting a lot of interest from AI chip developers. So that's, you know, that's why Grok was there with the S4X. Tenstorrent has said that they'll have one of their chiplets on S4X as well. And you know, Korea itself has a lot of AI startups.
If memory serves, Quasar is the SF4X chiplet from Tenstorrent.
From Tenstorrent, yeah.
Yeah.
Kevin seems down on HBM and in memory computing. So Samsung has actually shipped HBM with processing and memory on Xilinx FPGAs for years. They're on like their 3rd generation now. You might have to be a specific customer to go buy it and to get access to how to use it, but they've been generating revenue on it. So it's yeah, lots of things going on. And that is the end of the list. We are, I don't know, the timing's
almost
gone. 2 hours 20, almost 2.5 hours.
Yeah.
I started at 7 p.m. and I still need to have dinner. So we're going to sign off.
Lunch, so.
So we're going to sign off there. We've gone through so much, and really thankful for those of you who have stayed. If you like what George does, go to chipsandcheese.com. Go sign up for the Patreon there. Give those guys a hand. It is a 501c3, so it is tax deductible. Otherwise, my stuff, you already know the channel if you're here, or more-more.com. That's where my newsletter is. That's where we've seen some of the stuff here today. Or there's always merchandise. I think, George, you need to get Chips and Cheese merchandise.
Yes. I should get a bit cheese cup. Because
for sure,
out of coffee I drink.
We'll get it sorted. And also keep on Chips and Cheese, because George will be writing up his Snapdragon X Elite review there shortly. But yeah, thank you all for watching, and we'll see you next time.
Little hint: iGPU's coming first. Spicy.
Ooh, spicy. You gotta leave them on a cliffhanger.
Yes.
Take care, everyone.
Have a good one.